I was hoping to talk here about just a few things briefly. We have less time than previous days, and I don't want to go back too late to the room because there may be people heading off that want to talk or what have you. So I thought I'd talk about a couple things that you should be aware of when you use AnyLogic. And one of the things I alluded to yesterday with the whole thing with these intervention-oriented ability to define these dynamic parameters and so on. So I'm just going to open up the model from this morning. Oh, thank you. Yeah, it's not working for a very good reason because I don't have it connected. Thank you. Long day, long week, long month, long year.
You're robust.
Well,
of course, maybe you get recharged by
oh, it's a lot of fun. I'm having fun.
Keep telling yourself that.
Okay. So I wanted to talk about some things here. So the first of them was this notion of subtyping, and this is important. I could go into this in all level of details, but the basic deal with it, folks, is that you can capture in AnyLogic. AnyLogic itself captures, and you can capture commonalities amongst different objects by using this basic mechanism called subclassing or subtyping. And there's some subtleties, distinction between them that I don't have time to go into here, but where you'll find recordings of me online going into this. But the basic idea is, look, we can group things in the world into categories, and there's kind of hierarchies of categories, sometimes networks of categories. So, for example, radiologists and orthopedic surgeons are both types of doctors, right? Licensed practical nurses and registered nurses are types of nurses. Physiotherapists, doctors, nurses, chiropractors are all types of health professionals. Health professionals are types of people. And this is not merely an exercise in kind of stamp collection or classification for the sake of classification. By recognizing these categories, sometimes we can capture common mechanisms or common features of them in one place, rather than having to redefine them for each and every place. We could just do it in a single place. Yeah.
I'm trying to work on something very similar here. That diabetes, COPD, are a subset of long-term conditions.
Right. It's a similar idea. We can kind of group these things, and often we'll have a taxonomy of types we wish to model. Some of what I'm going to be discussing is also relevant when you don't have hierarchies, but where you instead have sort of networks of things, or just DAGs, directed acyclic graphs. But fundamentally, I'm going to concentrate for ease of reference on this case where of hierarchies. So, we may want to organize things into a hierarchy, right, where we have sort of person and patient and health professional. And we have doctors, nurses, chiropractors, and physiotherapists who are health professionals, and doctors have, several types of docs under them, right? A person interface, a person here might have certain common things that are shared by all of these folks. For example, they have an age, they have a name, they have sex, they have an ethnicity, etc. But as you go down the hierarchy, there might be more and more specific things, right? Like all doctors have a residency location, and a location, and I guess all the health professionals have areas where they trained. They may have areas of specialization. Health professionals may additionally have, patients with whom they're associated or what have you. So we have this kind of hierarchy of features, and as I say, it's not merely a curiosity, but there's sometimes benefit from recognizing this because we could take advantage of it in terms of our economy of expressing certain things. There's a lot of benefit from doing this because we can write, say, one thing that handles the case for a person, and it will handle all the rest of the cases also. We don't have to specialize it for each. We can kind of understand how things work better by sort of grouping them. We can, as I said, we can kind of write one set of things for the person and they work for all. And it's extensible. We can sort of extend more, have more doctors, and our system will work with them very easily. It'll handle all of them. So we can extend it easily. Now, there's a particular mechanism called polymorphism, which AnyLogic uses as part of it, where you can kind of pass. If you have a function which takes in an instance of a class, say person, you could pass in a radiologist, a reference to a radiologist as that. You could pass in a reference as a nurse to a person. If you had a function that handles any health professional, you could pass in a doctor or a radiologist. It would be treated as if it's a health professional, in terms of its being a health professional, in its capacity as a health professional. And it could do very general things there, and you wouldn't have to worry that it's actually a radiologist, because that's just a subtype of that. Okay, we get benefits out of this, and in AnyLogic, we have the ability to use these benefits. So, for example, we might have in our model a bat, and a bat is an agent. We might have a person is an agent. A deer is an agent. And, we might have a doe, and that's a type of deer, and therefore it's an agent. So we can capture these hierarchies, and AnyLogic actually does capture these. Whether you choose to exploit this functionality, like distinguishing men versus women, but having common characteristics of person, as I'll show you in just a minute, this hierarchy is there in AnyLogic with respect to things like agents. And occasionally you'll see this word agent come up, and you've got to realize sometimes, like, your person will be treated as an agent. Okay, be treated in terms of its agenthood. It will use that information to process it as if it's some generic agent, even though it's specifically a person. AnyLogic 7 is much less problematic for this. This used to be front and center, understanding common things in AnyLogic and overcoming common hurdles. But it's less common now, but you'll still see it popping out. And you should realize all behind AnyLogic, there's the structure. So it has multiple types of transitions, and all of them are transitions. And anything they create to sort of handle this, it will handle all of these transitions, okay? And this is behind the scenes what's going on in Java. All these things like list, a set, and a queue, these are all called collections, and we can iterate over all of them, etc. So there's a lot of things that you can pass to an object. You could pass, like, to an agent to ask, are you close to this person, or are you connected to this? And you may see this word agent. So let me see if I can create an instance of this. So here we have this model from this morning, and we have this isStateActive. Okay, we're not going to use that. We're going to add statistics, and I'm going to ask here item.is connected to. See how it says agent there? See how it says that? That might make you think, oh, I can't pass it another person because it needs an agent. But that agent, your agent, your person class, and a reference to a person class, to someone as a person, is also a reference to an agent automatically. So this will work just fine for your model. If you ask get... You can go to different levels of that hierarchy? That's right. You can go to different levels of that hierarchy. Here's another case. Get nearest agent. Here it returns something, and it's kind of confusing. It says extends agent, what that means is it's below, in that hierarchy, it's below agent. So it's somewhere in that tree of that agent sort of is on top of. It's somewhere down below agent here. That's what that extends. So I don't want to dwell on this too much because there's other things to show you, but just be aware that if you see things like agent, that it returns an agent, that's fine. It's going to return your class is an agent here. This used to be more of an issue because you'd have things which would require you to say, well, they're an agent, but they're actually secretly a class. Okay, this is actually a case where, okay, watch this. If I asked, I want to get the connected agent to myself. I'm a person, and, okay, actually, I'm going to get rid of this, and I'm just going to go make sure this is still operating. I'm going to go into person, and I'm going to go into on startup for person. And I'm going to ask for my connected agent, okay? Here we go, and this is get connected agent A, come on. Oh, it's not, there's no item, it's this. Because I'm in agent, I could say this, and let's go see, See, it returns an agent, do you see that? If I say, give me the first agent to whom I'm connected, it's going to return an agent. If I want to, now I happen to know that they're a person, because there's only persons in this model. So I could actually say, I want to call them a person, but to do so, I actually have to do what's called a cast, because all it knows is that they're an agent. It says, get connected agent, oh, it returns an agent. And if I tried to say person, something like this, I think it's going to complain. Yeah, it says, I don't know how to convert from an agent to a person. And you got to say, well, hey, buddy, they're actually a person, okay? Because there's only, those are the only types of people to whom I'd be connected in this model. So occasionally you'll get in a situation where it returns an agent and you have to say, look, it's a person. I know it's a person. Now, there's ways to actually ask, is it a person? But this is a way to tell it, basically, look, trust me, it's a person, okay? Just treat it as if, and it will check. It will check, and it will throw an error if it's not. But here, this get connected agent, it was written as if it's for all agents. It works for all agents. And therefore, it just knows to return an agent, and you have to tell it this is really a person. Less bad than it used to be for this, but it still occasionally comes up. Okay, so you should recognize. Does anyone remember where we saw this before? Yeah, you turn it into an int by having int. And basically, it's called a type coercion or type casting. It takes whatever this is, and it tries to turn it into one of these, to a reference to one of those, to reference to person in this case. So that's just something about these hierarchies. Now, can I tell you how these hierarchies are useful? Can I show you something where it's useful for you to take advantage of? This is AnyLogic. This has nothing to do with you, but can I show you where it's useful for you to take advantage of? It's very useful for AnyLogic, but let me show where it's useful to you. At least where it could be useful to you. Okay, watch this. Okay, I'm going to go open the example models I've given you. And there's one called, did I give you this one? That's the question. It's called HPV. There it is. Here we go. Sorry. This stuff is exciting. Okay, so let's go look at person. Here we have person. This model was built by no, it was actually built by two students, an exceptionally talented public health student, Karen Yee, together with Yudi, with a computer science student. Together they could accomplish wonders. And I'm hoping Karen will recognize it's in her her destiny to return. But I don't think that's going to happen. In any case, here we have a person class, and then we have males and females. Person class here captures certain general features of personhood. For example, they have different levels of sexual activity. They have different smoking patterns. Now, just because they have these categories doesn't mean males and females exhibit the same distribution over these categories or the same distribution over smoking. It's just this captures the common processes that are a part of them. And they have also aging processes that are in common. Look at that horrible thing. Why do we have this? Can you tell me? To divide up the initial population among these categories. Isn't that horrible? We're telling AnyLogic, try to get rid of it so it's simpler to show. Yeah.
Now, would person class then be useful for something like if you wanted to distinguish between
yeah.
pregnant women, well, women, pregnant women, children, adults, infants? Because they all would have an age.
Right. So I think here you could have common functions like is child, is adult, is is elderly or what have you. You could have those in common. The key thing is that by virtue of defining them here, now you can further define males and females. Let's show males first. Now, the important point is that, and this is the crux of the issue. Never mind with that. Okay, that's old stuff because this is AnyLogic 6 that we did this in, but now it's a lot cleaner. You see it extends person. That means it's sort of a type of person. It's one of those, it's beneath person in that hierarchy. And you see what's going on here? You have these things that are specific to men here, and then in the background, you also have the shared characteristics of being a person. So all those things are also characteristics of a male. They're just in the background in the sense that these male-specific characteristics are emphasized here. So see all these things here that are in the background that are common to all persons, whether they're a current smoker, whether they're in a low sexual activity group, are they vaccinated? Those are things common to all people. Why represent them separately for males and females? Just represent them one place, and this says this inherits all those characteristics, but it has some unique characteristics. Now, the world gets more complicated with the female class, because here we have a much more extensive set of HPV-related categories involving cervical cancer, etc. These are all layered. This is all based on a published model out of Merck, I think it was. But we turn into an agent-based model because this is horrendous as an aggregate model, stratified. It was just, it was horrible. And we wanted to extend it with smoking status, and it was, just terrible. You'd have to stratify it by that as well. Just horrible. But here we could actually make it, believe it or not, this is much cleaner than the SD model. Much, much, much cleaner. This model is looking for a nice foster parent to help advance it to its next stage to publish on it. Really, it seems just about ready. I mean, it's in great shape, but the students involved have gone the way of the Alberta. Actually, Yudi's still in town, but he's working 21-hour days. So, in any case, this is an example, of a situation where we define common characteristics on our own, and then we define subtypes that inherit from, that draw from, that are so-called subclasses of, that have all the characteristics of the parent class, but they have some additional specialized features that are of value to represent. Okay, so that's an example where you can use this subtyping hierarchy to good effect, and AnyLogic supports this now in a quite rich way compared to how it did before.
And does that happen when you create the male and female? You sort of carry all those characteristics over? Right.
You simply say this extends this other class, and it carries those characteristics for free. You don't have to redefine them. You don't have to redefine these common things which are shared by all, by males and females, or shared by all doctors. You could have 10 doctor types, 10 doctor classes, and they all have the basic characteristics of a doctor.
Can you just show us the mechanisms? When you hit that new agent
yeah.
You extend it, what do you actually do?
Yeah, I mean, in a concrete terms, and let's go over here. So SK observer. So if we wanted to extend this thing, I don't know why this is, okay, here. If we wanted to add a new class, we do new agent type, and we might say that this is a, for person, you know, we might say this is, I don't know, patient or something like that, right? It's a particular hey, oh, hello, oh, okay, well, you don't mind the misspelling. Okay, there we go, and we could scroll down, and you see how it says extends other agent? Okay, and I'm going to say it extends person, and by virtue of extending person, now you have all these characteristics of person here, but you can also define your own state charts and so on. Okay, so and you notice it has the parameters of person, it has their color, it has their little appearance, but now we can actually define additional state charts that would be specific to a patient, like whether they're in a facility or out of a facility. You see what I mean? Yeah. So that's what it gives you.
And so there, you don't mess with that state chart.
No. I can't.
The person one.
Right. I don't think I can edit this at all. I mean, it wouldn't make sense really for me to edit it. But you know, I might. Interestingly, I don't know. I mean, I haven't played around with this much in this version of AnyLogic. We did it in a previous version. But you know, here I might have care seeking state chart, right? And I might have a state here, you know, in care, and then, you know, at home or something like that, right? At home, and then I'd have transitions between them, and something like this. I don't know, and obviously I'm not trying to capture real world detail here, but you know, something like those lines, and this is going to be sure. So the back into in-care, this one was 0.01, something like that. Okay, ladies and gentlemen, by virtue of having this, now I could run this model and, first create a, okay, the interesting question is how could I trivially create these as part of the population? I think I can, but for the ease of doing this, I'm going to have a population separately of 10 patients, and let's take a look at this. Okay, here we have patients. Let's go dive down into patient population. See, now I can see both state charts. See that state chart in that one. See that? Yeah. So it has all the characteristics from this, but now it has this extra characteristic for whether they're in home or not, and you know they'll transition over time between. You can't see it, but I think it's flipping. At least it's counting down here. So, oh yeah, it's occasionally flipping back and forth. Yeah. In any case, that's subtyping, and it can be exploited by you. Just you should be aware that even if you don't particularly want to employ it in your model, you may occasionally have to face up to that fact through that thing we saw earlier, where you ask for my closest agent, it returns an agent to you, and you have to say, hey, look, trust me, it's a person. Does that make sense? Okay. Yeah.
Is that a direct reflection of the sort of the graphing of AnyLogic? That's sort of the class object relationship in Java. That's just a manifestation of heritability.
Well, yes, for the case. I mean, that's one of the reasons they use Java is because it has this nice feature, and this is a very nice feature for characterizing things in the world because we do have these taxonomies, these hierarchies of sort of related things, and they are. It's fruitful to be able to capture those hierarchies, and so you use one of the reasons Java is so popular is because it can capture these hierarchies, and AnyLogic has simply used that in building their software on the one hand, and then now exposed it to the user. This is really a kind of an AnyLogic 7 push Before then, it was sort of half. It was workable if you kind of had lots of workarounds, if you had sort of workarounds and so on. But now it's sort of, I think, hitting more prime time. You can use it much more easily. And someone like Dylan would be all over this. So you could capture these kind of common characteristics without redefining it. Like you don't want to have to go redefine, these common characteristics that are shared among all these things. You could define it once, right? So think about, you could define common aging processes, once. Things to give people serial numbers once. And then you have these different classes, subclass it, which remove things from it, which specialize it in different ways. Does that make sense? Okay, I know that was a bit whirlwind, but I want to show you one other thing before the end. Is that okay? Okay. So that was, brief comments on subclassing.